Hello, welcome to our channel. In this video, we will look at some examples of compound linear inequalities. So compound linear inequalities are just two inequalities combined by using and or to create another inequality basically. All right, so here is our first example. Here we have -2 less than 2x plus 6 less than or equal to 10. Our goal is to isolate x. So the first step, we will subtract 6 from each part of this inequality. So subtract 6 here, subtract 6 here, and subtract 6 here. So we need to do that to each part of this inequality. We have 3 parts. So we need to do the same thing to each part over here. So when you do that, what do you get? -2 minus 6 is -8. Less than 2x plus 6 minus 6 is 2x. Less than or equal to 10 minus 6 is 4. So we get this. Next, we can divide each term here by 2. That way we'll have just x in the middle. So this will give us -8 by 2 is -4, greater than x is less than or equal to 2. So this is the solution. X is between -4 and 2. If you put this on a number line, let's see how it will look like. 0 is somewhere here, 2 is here, and -4 can be somewhere over here. So x is between -4 and 2. X is strictly greater than -4 and less than or equal to 2. So it will be all real numbers between -4 and 2. So therefore, the solution is, if you like to write in this interval notation, so all real numbers between -4 and 2, not including -4. That's why we have this parenthesis here. But including 2, we have a square bracket here. So this is the solution to this inequality. Right, so let's look at the next example now. This is similar to the previous one, except we have some fractions here. Now, whenever we have fraction, I think the best way is to try to get rid of the fractions first. So we can do that by multiplying each part of the inequality by what we have in the denominator. So for example, if you want to get rid of this 3 in the denominator, we multiply each part of the inequality by 3. We have 3 parts here. So if we do one thing to one of the parts, we need to do the same thing everywhere. So if you multiply the first one by 3, we need to do the same thing to those two also. So to do that, let me copy this whole inequality down here so that we have more space to work. Okay, so the first step, we can multiply each part of this inequality by 3. Like that. So 3 times 2 by 3 is simply 2. Less than 3 times 5 by 4 is 15 by 4. 1 minus 3x, less than or equal to 3 times 10 is 30. Okay. Next, we need to get rid of that 4. So multiply each part of this inequality by 4. Like that. And let's see what that will give us. 4 times 2 is 8. Less than 4 times 15 by 4 is just 15. 1 minus 3x, less than or equal to 120. So this is what we get. Next, we can try to simplify that middle part by distributing 15. So that will give us 8. Less than 15 minus 15 times 3x is 45x. Less than or equal to 120. So we have a nice linear compound inequality. Now we can try to isolate x. We can try to remove this 15. So for that, we can subtract 15 everywhere. So that will give us 8 minus 15 is -7. Less than 15 minus 45x minus 15 will be negative 45x, less than or equal to 120 minus 15 will be 105. So this is what we get so far. We still need to isolate this x, so we need to get rid of negative 45. So for that, we can divide everywhere by negative 45. Like that. But whenever we divide by a negative number, we need to flip the sign of inequality. So that will become like this, and this will become like this. So let's see what that will give us. So negative 7 by negative 45 is 7 by 45 here. So it becomes greater than. We are left with just x in the middle. Greater than or equal to 105 by 45. So that we can simplify a little bit. So this is the solution. X is between these two numbers. Now let's try to put it on a number line so that we can write it as an interval. I'm going to draw the number line up here. So we can put 0 over here. We have negative 7 by 3 here, and we have 7 by 45 here. So we are looking at all real numbers between negative 7 by 3 and 7 by 45, including negative 7 by 3. So we can include that number, and we cannot include that number because it's strictly less than 7 by 45. So that means the solution, I'm going to write it here, is negative 7 by 3. I'm going to include negative 7 by 3. So we have a square bracket here and 7 by 45. So this is the solution. So we are done with this example. Let's look at the next one now. So here we are given a compound inequality as two inequalities connected by AND. So the same process will apply. So to solve this, we just need to solve these two individually, and then at the end connect the two solutions by AND. So let's try to do that. Here you want to subtract 6 from both so that we can isolate x. So this will be negative 8 less than 2x. And then we can divide both of these by 2. So we get negative 4 less than x, or you can write this as x is greater than negative 4. So this is one solution. Solution to the first one. Solution to the second one, again we can subtract 6 from both. So we get 2x less than or equal to 4. And then we can divide both of these by 2. So x less than or equal to 2. So this is the solution to the second one. Now to get the solution of the whole thing, we must find value of x that satisfies this one and this one, because we have the conjunction and over here. So we must look for x values that satisfy both of these conditions. So to find that, to figure that out, let's put these two solutions on one number line. So 0 we can put somewhere here. Let's say negative 4 is here and 2 is over here. The first one says x is greater than negative 4. Is strictly greater than negative 4. So negative 4 is not included, like this. So this is the solution to the first one. And the second one says x is less than or equal to 2. So we can include 2. So we have a solid dot above 2. And less than or equal to 2. So this is the solution to the second one. Now we need to look for x values that satisfy both of these. If you pick a number over here, looks like only the second one is satisfied. So we can't include anything in that interval. If you pick a number over here, looks like this is satisfied and that is also satisfied. So both of them are satisfied. So any number over here is good, because any number over here satisfies both of these inequalities. And similarly, if you pick a number over here, only one is satisfied and two is not there. So any number over here is not good. So the solution is all real numbers from -4 to 2. We can write as interval. And we don't include -4. So we use this parenthesis here. We include 2. We use square bracket here. So this is the solution. Right, so we are done with this example. Let's look at the next one now. Again, a similar situation here. We have two inequalities connected by AND. That means we need to solve these two individually and look for x values that satisfy both of these at the end. So let's try to solve these two individually. So first we can add, to solve the first one, we can add 10 to both sides. So that will give us 6x minus 10 plus 10 is 6x. Greater than 2 plus 10 is 12. So 6x greater than 12. And then we can divide both sides of this by 6. So we get x greater than 2. So this is the solution to the first one. And to solve the second one, let's first distribute this 5. So we get 5x minus 15 less than -20. And then we can add 15 to both sides here, plus 15, because we want to get rid of that -15. So we will get 5x less than 5 over here. Well, -5, -20 plus 15 is -5. And the last step, we can divide both of these by 5, because we want to get rid of this 5 in front of x. So that will give us x less than -1. Okay, so this is the solution to the second one. So that means the solution to this compound inequality will be all real numbers that satisfy both of these, this one and that one. So to figure that out, to look at the real numbers that satisfy both of these, let's draw a number line. Let's put both of them on a number line. So 0 is somewhere here, -1 can be here, and 2 can be somewhere over there. So if I call this 1, x greater than 2 is something like this one, x strictly greater than 2 is all the numbers to the right of 2. So this is the solution for 1. And for the second one, if I call this one 2, we have x less than -1. So all the real numbers to the left of -1. So this is 2. Now we need to look for x values that satisfy both of these. If we look at a real number over here, it satisfies 2, but not 1. There is no graph for 1 above this real number. So any real number over here will not work. If you look at real number over here, so there is no graph at all above that real number. So it doesn't satisfy any of those two. So any real number will not work. If you look at any real number over here in that interval above 2, it satisfied the first inequality, this one, but not the second one. There is no graph for second one above this real number. So this is any real number here will also not work. So there is no real number x that satisfies both of these. That means the solution is empty. There is no value x that satisfies this compound inequality. So if you step back a little bit and think about these two over here, x greater than 2 and less than -1. Well, there can be no real number x that is greater than 2 and less than -1 at the same time. So x greater than 2 means it must be positive. Less than -1 means it must be negative. There is no real number that is both positive and negative at the same time. So the solution is empty. All right, so we are done with this example, and this is all I have put together for this video. Thank you for watching. Have a good day.